Hello everybody. I'm ready to show you guys my latest project that I finished. I call it Geiger Counter IoT. This is basically a Geiger counter that is the Mighty Ohm Geiger Counter Kit, which you can purchase and build your own Geiger counter. It's pretty cool. And then I did my own hack to it so that I could read the electrical pulse from the LED using this ESP8266. And I'm also doing some data storage. I'm logging the data. And the way I have it set up, you can get about, well, you can get more than that, but more than this, you can get 45 days of continuous minute-by-minute updates, all stored on the ESP. So it's also got a web interface, which I'm going to show you. See over here. And we're going to do some testing with a few different materials that I obtained that are slightly radioactive. Alright, so first I'm just going to show you what we got going on here with the GUI. This is the new improved version. I had an earlier version out on a couple earlier videos where one of these was a battery indicator. I have since gotten rid of the battery indicator and created 3 dials for the radiation. Excuse me, I've had a cold, so I might cough a couple times. This is for testing low emissions, basically. So we're just testing background radiation right now, and the last reading was 0.07 microsieverts per hour. I'm not sure if I'm saying that right. And clicks per minute, 17.76. These are the averages for the last 4.79 minutes. And you can see the values here. Alright, so what I'm going to do now is show you a little bit about how this works. So I took the battery indicator out and basically just put the voltage down below the chart here with the Wi-Fi signal. I figure this is a Geiger counter application and not a battery monitoring application. And I'll try to show you that here. If I can get my browser to work the way I want it. Give me a sec. Alright, there it is. The Wi-Fi signal strength and the power that the Geiger counter has from the ESP device. Alright, so this is the latest, greatest version that I've created. The session's been running for 6 minutes, and I like to get a little baseline values right here. That way, if I'm testing something that's not got that much emissions, I can subtract this value and get the actual value that the object is emitting. And this is for medium and for high emissions, and this is just showing you the data minute by minute over time. So every minute, approximately every minute, it will take the reading and store it to a data file. And I'll show you those here. And it will store up, let's see, 1,440 lines of data, which is 24 hours of data in one file. And I've got it set up right now to max out at 45 files. You can set that higher or lower if you want. You don't want to create too many files, otherwise the system's going to crash just because there won't be enough space to do it. Alright, so at 45 files, it's just going to stop writing data, and it'll display a message telling you the data is full, and you're going to have to come here and clear the data, which will wipe out all the files, and then it'll start logging again. So I just hit back, so we're headed back to the first page, but I didn't actually show you what we can do here. You can actually download these files. If you click on any of these files, Go on back. Click on any of these files, you can download them. So I'm going to go ahead and download this one here. Now it might take a little while, just because it can have up to 1,440 lines in it, and it can take a little while to download the file. Let's see what it takes here, and while we're waiting for this file to download, I'm going to go ahead and get the first piece of material that I want to test, which will be some lepidolite. And as you can see, it's starting to download file. And I guess I'll go ahead and let it finish, although it's probably got a lot of records because it's probably about to start a new file. It's been going for a couple days. And I've got my lepidolite here to test with. This is something I picked up at the local crystal store. I saw this website, Radioactive Gems, and showed it to the owner of the store and said, hey, you got any of these things? And apparently most of them were very rare, but he did point out a few, and they were very low emission. So anyways, I thought I'd go ahead and give it a try. So let's go back here. We can just let that file download. And we're going to start testing our lepidolite. But first I'm going to reset the session, since we've been testing the background radiation to get a baseline. I'm going to reset the session so that all the averages and everything reset to 0 so that we can get an accurate reading with the material. And it's a little slow trying to download this file. And it's done, finally. I'll show you the data. There you go. So that is basically the data that is being stored. And it's basically the same data that I'm displaying for the Google charts. So you can change that data in the code if you want to store whatever values you want. Alright, so you can see here that during that download, it kind of slowed down. In other words, counting was continuing, but it probably skipped a couple minutes because it was busy downloading this file, which no harm done. The count is still going, and we'll probably see this drop way down at some point. It'll average out. But I'm going to reset this session so we can test our lepidolite. Alright. Now this is going to set the values back to 0 and tell us that we need to refresh the page, otherwise it's just going to stay on that static page there. Alright, see all the values are back to 0 now, and see how it dipped down, so it averages out. And go back to refresh mode, where it refreshes every 60 seconds. And we're going to put our sample in here. Alright, so here's the lepidolite, and we'll just give it 5 to 10 minutes to get a good reading. As you can see just by listening to the beeper and watching the light, it doesn't seem to be much. So we'll just we'll let it go for a few minutes to see if we actually can see any kind of difference in the charts and the data that we get as an average over 5-10 minutes or so. So I'm going to go ahead and speed up the video so we can go ahead and take a look at that information now. Alright, we've been going for about 10 minutes here, And we can see that our average is 0.16. We've gone up to 28 clicks per minute. I think the average before was around 17, and this was about 0.1 or something. So we basically have a very low emission object that we're testing with about 0.06 USVs per hour. All right, so now I'm going to test what's called Vaseline glass or depression glass or uranium glass, which ought to give you a clue. And you can get these items on eBay. That's where I got them, in case you're interested in doing this and testing it all out yourself. And I bought this little piece here, and now we're going to give it a test out. All right. You probably already tell that it is going a little bit faster. The other object, is very difficult to tell any difference between that and background radiation. However, I'm going to reset the session here. It does show that this can be a pretty sensitive device. You can use it to test very low emissions to relatively high emissions. I mean, it's going to max out at a certain CPM. I don't really know what that is, and don't really want to find out because that would probably be unhealthy. In fact, one of these objects that I purchased, well, you'll see. I'm going to test it in a little bit, but we're going to let this go for, another 5-10 minutes, and I'm going to speed this up so you can see what this object's emissions are. All right, it looks like we have about 15 minutes of data testing the Vaseline glass, and as you can see, it is definitely higher than the Lepidolite. All right, so this one's getting 104 on average for the 15 minutes and 0.6 USV. So this is changing minute by minute, but this is the average. So that's what you get with this Vaseline glass. And you can subtract 0.1 from this, and you're getting about 0.5 USV per hour. All right, now I'm going to go ahead and test some Fiestaware. I also purchased this from eBay, and there's all sorts of different pieces out there. I got this nice small salt shaker, and I'm going to go ahead and get that. I'm going to reset the session here, get my other piece. And here we go. As you can see, it's pretty obvious this thing is much higher than the other objects we tested. So we're going to go ahead and reset this and let it run for 15 minutes or so and check our data. All right, it's been about 15 minutes now, and as you can see, the Fiestaware is way higher than the Vaseline glass or the Lepidolite. In fact, you can see down here where the glass was being tested, and it's just way lower, but it's nice. You can actually get a comparison between two different objects, and you can barely even see the Lepidolite. If you can see it all, it's so close to background radiation that you can just barely see it. And as you can see, we're at 2,600, almost 3,000 counts per minute. And the average USV is up to 15.37. So we're tacking out both of these guys, but you can still see it here on the high emissions scale. This is probably not the healthiest type of container to be storing salt or any other shakeable in. But that's Fiestaware. If you're going to get some, you get the orange stuff if you want to use it to test radiation. I haven't tested anything else, but I hear that the orange is what has the uranium in it. Anyways, I hope you enjoyed my demonstration and the tests we did. And if you did, please subscribe and like the video, and keep tuned for more projects. Thanks.